Let's see. We have a Venn diagram given, and there's two sets, and the probability of each of those sets is given. First thing is, we want to find the probability of A. So what does that mean? That essentially means what's the total probability of the circle A, essentially. So what do you guys think? I mean, when I say A, I mean the whole circle A and nothing else, right? So that's the sum of everything in A, right?
Yeah.
So 0.4 minus x plus x. Because A could happen alone or A could happen with B. Either way, A is happening. So that's why I add the alone part and the with B part together, which gives me just 0.4. Is this clear?
Mm-hmm.
Perfect. Part B is write down the value of x given that A and B are mutually exclusive. So this is something I haven't explained yet. But what is mutual exclusivity? Oh God. Mutual, let's say mutually exclusive events. The idea is simple. Two events are considered mutually exclusive if they cannot happen together at all. Okay. For instance, like getting a 7 on an IB exam and failing the exam. Those two events are impossible that they occur at the same time, right? Or it being sunny and raining, that's also impossible. So those two events are mutually exclusive. How do we say this in probability? We say that the probability of their intersection, meaning the probability of them happening simultaneously, is zero. That makes sense, doesn't it?
Yeah.
Perfect. Which means that, um, yeah, so that's essentially it for now. That's all you need to know for now. So if two events are mutually exclusive, that means that they have no intersection, which means that x must be what? This number. What must this number be if A and B are mutually exclusive?
0.
Zero, exactly, because they're not supposed to have an intersection, so the probability of them happening together would be zero. So x must be zero. Okay. Now, next question is another thing that I haven't explained yet, but this is a good place to learn it. How do you check if two events are independent? Now, a lot of people mix up independence and mutual exclusivity. Independence means if two events are independent, that means that one thing happening will not affect the probability of the other thing happening. Okay. So for example, if I roll a die and I get a 6, it will not affect the probability of me then flipping a coin and getting a heads, right? Because those are independent things. They don't affect each other's probability. However, if, for instance, I win 3 games in a row of football, that does affect my probability of winning a fourth game because it's not a probabilistic thing. It's not like the previous 3 games are independent of the fourth one. If I keep winning, that must mean that I have a higher probability of winning again. So, and how do you check this in, mathematically? Simply check if the probability of two things happening. Uh, there's a bunch of ways to check it actually. You can check if the probability of A, given that B has happened, is the same as the probability of A. Why? This is actually very logical. If I tell you that A and B are independent, meaning B happening will not affect me knowing that A is going to happen more probably or not less probably, etc., etc. So if I give you a conditional probability, like, hey, can you tell me that what's the probability of A happening if I already tell you that B has occurred? And you tell me it's the same as the probability of A happening anyway. That means that me telling you that B has occurred did not affect the probability of A occurring, which means that A and B are independent of each other, right? This condition, this information that I supplied to you did not affect your knowledge. It did not affect the probability of A happening. You see what I mean? So if this holds for A and B for two events, then they are independent. So we need to check the conditional probability of A happening given that B has happened. So let's try to find that out. If I tell you that the probability of, sorry, if I tell you that B has occurred, that means we are in this zone. We're talking about this, situation. So we're only talking about this, like this is our sample space now, essentially. So out of that black circle that I've made, why have I made that black circle, by the way, again? Because my condition is that B has already occurred. Okay. What's the probability of A occurring now? So there's a formula for this. The formula for conditional probability is A intersection with B divided by a probability of B in general. Okay, this is the formula. So we need to find out what this is equal to. So what is the intersection of A and B? It is X. And what is the probability of B in general? Can anybody tell me what the probability of B is? So when I ask you for the probability of B, I mean what's the total probability of the circle B?
Would it be 0.3?
No, that's just B alone. So that's just this part. That's not the whole circle of B, is it? The whole circle of B is this. It's 0.3 plus X, right?
Hmm.
Perfect.
I was
So,
just thinking if x is 0.
sorry? No, but
I was,
this is a different question. Given that now it's a different situation, so we're not considering that X is 0 anymore.
okay.
So this is the probability of A happening given that B has occurred using the conditional probability formula, which is this. Okay, this will be given in your formula booklet, by the way. Now, and what's the probability of A happening anyway? So, what's the probability of A using the Venn diagram? Come on, guys.
0.4 minus x plus x.
Exactly. 0.4 minus x plus x, which is just 0.4. So we found the probability, so the conditional probability of A happening given that B has occurred. We have also found the probability of A happening. And I've already told you that if you want two events to be independent, then you need to follow this requirement if they are independent. If two things are independent, then this requirement must be followed by them. Okay, so which means that I want to find the value of x such that a and b are independent, which means that we need to set these two things equal to each other because this is what is required for independence, right? We want the conditional probability of a given b to be the same as the probability of a anyway, because given b doesn't affect the probability of a if they are independent. So that is why I'm setting the conditional probability of a given b to the probability of a, and I'm going to solve this for x. Does this make sense to you?
Yes.
Okay. Jessica, Amy, everything good?
Yeah.
Okay. So there's three new things that you've learned so far, by the way. Let me just kind of revise, like tell you them again. Number one, if two things are mutually exclusive, they have zero intersection. For two things to be independent, this must hold for those two things. Okay. This is how you calculate conditional probability using other probabilities. This is called the conditional probability formula, essentially. And that's basically it. So I'm going to set these two equal to each other because I want independence. I will multiply both sides by 0.3 plus x, sorry, which gives me 0.4 times 0.3 is, I believe, 0.12 plus 0.4x. I'm going to subtract the 0.4 on the left side, and I'm going to divide both sides by 0.6 now, which gives me 2, I think? No, 0.2 or something. One second. Yeah, 0.2, isn't it? So x must be 0.2 if I want them to be independent. Okay? Why? Let me show you why. Why must x be 0.2 for a and b to be independent? Because if x is 0.2, the conditional probability of a given b will be 0.2 over 0.5, according to this formula, by the way, which is 2 over 5. And the probability of a anyway would just be 0.4, which is, by the way, which is, by the way, 2 over 5, which means that if x is equal to 2, then the probability of A happening given that B has happened is the same as the probability of A happening anyway, which means that A doesn't care about whether B has happened, which means that A is independent of B. Is this idea clear now?
Yeah, kind of.
Okay. So Okay, so to check for independence of two events, find the conditional probability. So find, for example, if the two events are A and B, find the probability of A given that A happening given that B has occurred by using this formula. That's step one. Then find the probability of A happening in general using just the Venn diagram, full circle of A, the sum of these two. And then if you want them to be independent, realize that they must be equal. This must be equal to this. You get an equation, solve that equation for x, and you will get the value of x that you need for independence. This red part over here is just me explaining how x being equal to 0.2 makes them independent. This is not part of the problem. It's just me explaining to you. Next up, we have find the value of x. Let's put this down here again. The next part is we need to find the value of x such that probability of A given B is equal to 0.5. Okay, let's first try to make a formula for probability of A given B using the definition of conditional probability, which is this. Okay, that's the formula for conditional probability. Again, this is always going to apply. So, can you guys tell me what is probability of A intersection B? According to the diagram.
X.
What is the probability of B according to the diagram?
X plus 0.3.
Exactly. Now, I want this probability of A given B to be equal to 0.5. So I will set it equal to 0.5 and I just have to solve this for x now. Does this make sense? So whenever someone asks you to find a conditional probability or like gives you a value for it, whatever, remember that this is the formula you need to use. Okay?
Yeah.
Perfect. So we just need to solve that equation now. I'm going to multiply both sides by the bottom, like basically multiply there, which gives me x equals 0.5x plus 0.15. I'm going to subtract the 0.5x on the left side, and I'm going to divide by 0.5 on the right side now, which gives me 0.3. So x would have to be 0.3 for this to happen. Okay, I'm going to leave the last part to you guys to figure out. This is homework. And does everybody understand the ideas?
Yeah.
Okay. So again, mutual exclusivity, independence, and conditional probability formula. Those are the new things that I've taught you at this point. So I'm just gonna this, and this is extremely important. This will be given in your formula booklet, but still make sure you are familiar with this idea. Okay. Okay. Any questions by anybody?
No.
Okay. What's the next one that you guys want to work on?
I think it was. Hold on. 12 and 41.
12. Let's take a look at 12. This is also a good question because you have to generate the Venn diagram yourself this time. So let's take a look. So we have a bunch of students. 40 take chemistry, 30 take physics only, 20 take both, and okay, this is very easy actually because they made it for you. So physics, chemistry, and this is the universal set. We can call it like this. Okay, so what should I put where? Jessica, where should I put this number? 40.
On the right side circle.
So over here or over here?
Over there, the other one.
The right side, right?
Mm-hmm.
Okay. What about physics? 30 take physics only. Amy?
30 take physics, so that would be on the left side, but not in the middle.
Yeah, because it says only, specifically only physics, because this would be both, right? 20 take both, and 60 take neither. That's basically it. So they didn't really leave you with anything to find out yourself. The first part is probability that someone takes physics given that he takes chemistry. So use the formula for conditional probability to tell me what I need to calculate. What do I mean? Like, don't tell me what the thing is, just tell me what it looks like in this form, basically. What do I need to calculate here? What do I need to calculate here? Okay. So, Amy, try that. Tell me what the formula is going to look like.
Okay. So
By the way, you can scroll up.
P. So that would be 20 over.
Can you say that again? I didn't hear you.
40,
My
right?
headphones turned off.
Would it be 20 over 20 plus 40?
That's exactly perfect. Yes, good. However, I was expecting more of a answer like this one, and then I was gonna put the values in. But yeah,
Sorry.
that's exactly perfect. So we're gonna have 20 intersection over all of C, which is 60, which gives you 1 over 3 basically. Nice. Okay. So I think you understand how to do this now. Okay, so I'm gonna leave you guys with the rest of this as homework. So basically, this and this part are your homework now. Any questions, by the way, about this?
No.
Okay. And what's the next one?
41.
Damn. What's with the jump? You said 31 or 41?
41.
Ooh. Okay. Maybe. There's something called the addition formula. Did I talk about this before?
I don't think so.
So the addition formula for probability is. Does anybody know what this is, by the way? Does anybody know where I'm gonna go with this? No? Okay. So essentially, if you have two events and you want to find their union, okay? Union means that if I have two events, like for example A and B, union means I want to add up everything, basically. Okay? However, there's a little issue. If I just say that this is equal to probability of A plus probability of B, it won't really work because look, because I will have probability of A, which is all of this, and then I will have probability of B, which is all of this. And if I add them up, what's the problem? What's the issue? Don't they add up to all of this? Does anybody know what the problem is if I directly add these two and say that it's equal to this? Use basic logic. Like, it's not a mathematical question. It's just a visual question, honestly. Why is that not equivalent to the left side?
It just looks like it's gonna overlap twice in the intersection.
Yes, so we're gonna add the intersection 2 times, right? Once with A, once with B, right? So what we do is we just subtract one of those intersections to make it, fit better. To make it fit correctly, actually. So we can subtract this part once, which makes it exactly equal to that. Because otherwise we would be adding it twice. You see what I mean?
Yeah.
So this is called the addition formula for general purpose. Can you tell me what difference would it make if the two events were mutually exclusive? Anybody? What does it mean when two events are mutually exclusive, by the way?
0. X is 0.
I mean, in that specific question, yes, x would be 0. But in general, what does it mean?
They cannot happen at the same time.
They cannot happen at the same time. That's a good way to say it. What would it look like on a Venn diagram if two events are mutually exclusive?
Is it that it's gonna be that the intersection isn't colored in, everything else is colored in?
There's a misconception. So if two things are mutually exclusive, it's not that I'm not choosing to look at their intersection. It is that they literally do not intersect. They're separate circles.
Oh,
You see? So I should have drawn that actually. By the way, you cannot see any such visual things in an independence case. Independent events you have to actually check mathematically. But mutually exclusive, it's very obvious. They just don't meet because they don't have an overlap. Okay. So what would change in this addition formula if two events are mutually exclusive?
So the circles wouldn't be overlapping.
So what would change in the formula then, mathematically speaking? Would any term be added or subtracted from here?
Well, you wouldn't have to add the
Yeah, you wouldn't need this part.
yeah.
Yeah, because there is no overlap, so you're not counting anything twice if there's no overlap, so you don't need to write this term. Of course, you could, but then you would just have to plug 0 for it because they're mutually exclusive. So this is a general purpose formula, but of course it will become a bit simpler if two events are mutually exclusive. So I'm going to put this here on the right, and then let's look at this question. Now, given that these two events are independent of each other, and we are told the probability of A intersecting with B and the probability of A intersecting with not B. Wow. So let me show you what this means on a Venn diagram. If this is A and this is B, A intersecting with B is 0.3, which means that we have a little 0.3 sitting here, right? Now, what is this though? Can anybody tell me which section of this Venn diagram is corresponding to A intersecting with not B? So not B, by the way, means everything in this diagram except B, by the way. Right? So literally all of this. And A is just A. So what is the intersection between A and not B?
Oh.
It's more of a, again, a logical question than a mathematical one. You'll have to kind of just imagine this, another, what's the word? The overlap between not B, the section that is not B, and the section that is A. So try to, like, color them in your head and try to see what the overlap is.
is it like the whatever isn't B minus whatever is B?
No, I'm talking about just shading the area. So which area does that correspond to?
Just anything that isn't B.
Anything that is in B. So all of this.
Yeah.
No, but then A intersecting. So this is just not B. This orange stuff I've drawn, this is just not B. But we want the A's commonality with not B, not just not B. We want what is common between not B and A, basically. Now, what is A now? A is this. So what's the commonality? The common part between those two is just this. You see what I mean now? That's the common stuff between not B and A. So, one second. This is A intersection with not B. Do you guys see what I mean now?
Yeah.
This is the common part between A and everything that's not B. Are you sure this makes sense? Okay.
Yeah.
Which means that I can put the 0.3 over here now. Okay. Now what am I trying to find? I'm trying to find A union with B, which means that I need to know this missing part. Okay, and honestly, there's nothing that is given here that can help me find that missing part, except I know another important little idea. I know that A and B are independent of each other. Okay? Now, if two things are independent, they must follow this rule. Right? And similarly, they must also follow the other way around, like B given A must also be true. Sorry, I haven't even put the rule down first. Wait. So this is the conditional probability formula, right? This is just the formula you use to find conditional probability. But if you want A and B to be independent, then this must be equal to directly just probability of A. And if you want conditional probability, if you want them to be independent, this must be equal to just probability of B. If either one of these two things hold, then you have a independent pair of events. Okay? Because if the probability of A happening, if I tell you that B has happened, is the same as A happening anyway, that means that me telling you B happened doesn't make a difference, which means that A and B are independent. And similarly, I'm not going to say it again, but that's the idea. So maybe by using this formula and calling the probability of B X, I don't know what it is yet, I can try to find out what X is, because that's what I'm trying to find, right? I'm trying to find what goes here. Okay, so since they are independent, this must hold basically because of independence. Now, what's the probability of B intersection with A? 0.3. What's the probability of B? I don't know. What's the probability of B? I don't know. This is a simple equation to solve. Multiply both sides by x, square root both sides, and get the answer. The square root of 0.3 is x must be 0.548 basically, which is a bit worrying because I just realized then 0.3 plus 0.3 plus okay, never mind. So this is x. Now it might be very tempting to write 0.548 over here and call it a day, but do not do that, because you should notice that if you add these three, it's already more than 1. How is that possible? Right? So my question to you now is, why is this not 0.548? Didn't I just calculate what P of B is? Oh, I just calculated in front of you what P of B is, right? It's 0.548. So why is this not 0.548? Why can't I write it there?
Because it needs to be like you need to subtract 0.3.
Beautiful. Because P of B is not just this part, it's all of B, which means that all of this must add up to 0.548, which means that just this part is 0.548 minus the common part, minus 0.3, which leaves me with 0.248, which means that this is 0.248, which makes the whole thing equal to 1. It might not, by the way, because there's some part that's outside also, but it's less than 1, and that's all that matters, because it can't be more than 1. Probabilities must never sum up to being more than 1. It does not make sense. Okay. So the main takeaway, but okay, so now we just have to find the probability of A union B. We can find that by adding A, B, and subtracting the intersection, or because we already have the Venn diagram, we can just add this, this, and this and call it a day. 0.3 plus 0.3 plus 0.248, which is whatever. That's the answer. Now, the main takeaway I want you to take from this question is, if you are told two things are independent, this is how you check. This is the thing that proves that two things are independent, this equality. If the probability of B given A, which is by the way equal to this according to the formula, is equal to the probability of B anyway, they are independent. Similarly, if the probability of A given B is the same as the probability of A, they are independent. Okay? This is what it means to be independent. Is this clear?
Yeah.
These are tough ideas, by the way. That's why I'm spending so much time on them. Make sure you understand these fully. If you don't, we can talk about some easier questions next time. Let's look at question 41, which is a much more difficult looking question of Venn diagrams. So we have a group of 16 students. 12 take art, 8 take music, 1 takes neither. And okay, we need to first start building on from what we know. First things first, I know for a fact that one person takes neither, which means that S must be 1. Right? Now, if 12 people take art and 8 take music, right? I don't know how many people take both. Okay? However, I do know that P plus Q is 12, right? And I know that Q plus R is 8. Correct?
Yeah.
This must be 12 and this must be 8, because that's what they told me.
Oh, that's where I got it confused.
What did you get confused on?
So I thought that like 12 was just P,
P.
and 8
No,
was just R.
that's the point. So when they tell you, like the size of one full circle, the problem is that we don't know how many are taking only that circle and how many are in that intersection. That's the whole point of these Venn diagram problems. If you check the recording, by the way, from the last class from Venn diagrams, you'll see that the example I did is a very similar situation where we don't know the intersection, but we know the full circle. Okay?
Yeah.
Anyways, so we have this now. Okay, what else do we know? By the way, the problem is we don't know three things here. We don't know P, we don't know Q, we don't know R. And we only have two equations. It's impossible. We can't solve this. However, we do know the total number of people in the classroom, which means that we know what P plus Q plus R plus S, which is 1, by the way, is 16. So now we have three equations and three variables which should be possible to solve. So let's try to figure out a method to solve it. What I'm going to do is I'm going to use my third equation. No, I'm going to use my first equation to say that T equals 12 minus Q. Is that true?
Yeah.
From the second equation, I'm going to say R equals 8 minus Q. Why did I do that? Because now I can replace P with a Q thing and R with also a Q thing, which leaves me with 12 minus Q for P, because the first equation told me so, plus Q because it's already there, and plus R because the second equation told me that R is 8 minus Q. I'm going to put that there. And then I have a plus 1, and then I have an equal to 16. This is basic like substitution, solving simultaneous equations using substitution. So this should be obvious to you. If it's not, yeah, I'm planning on doing a class where we talk about solving equations. This can be part of that. Is this clear?
Mm-hmm.
Now we can just simplify. So minus Q plus Q cancels out. 12 plus 8 plus 1 is 21. Minus Q equals 16. I can subtract 21 on both sides, which will give me negative 5. And then I can cancel out the negatives, which gives me Q equals 5. Boom. Okay. So this idea, the fact that there's a loner part and there's a both part, which you have to add to say that that is what equals 12, not just one of them. Okay. Of course, if they told me that art and music are mutually exclusive, then I would immediately know that this is 0, which means this must be 12 and this must be 8. But they never told me that, right? So I have to, remember that this and this add up to 12 and not one of them are 12. So using Q, we can now find R and P easily because we can just plug it back here and back here, right? So P is going to be 12 minus 5 and R is going to be 8 minus 5. So we have found P, Q, R, and S. Just to confirm, so P is 7, Q is 5, R is 3, and S is 1. If I add all of these up, they will be 16. 7 plus 5 is 12, 12 plus 3 is 15, 15 plus 1 is 16, exactly as expected. Right. So now that we know all the numbers, what's the probability that a student selected at random, given that this person takes music, what's the probability that they also take art? So for this, again, we're going to use the conditional probability formula. Probability of A intersection with music divided by probability of music in general. So what's the intersection? 5. What's the total probability of M in general? It's all of M, which is 8. That's the answer. This is that easy, basically. Okay.
Yeah.
Now, because we know the probability of taking art, given that you are taking music already, we need to prove that these two things are not independent of each other. So if two things are independent, what would be the case? For example, if A and M were independent of each other, what would this have to be equal to? What's the requirement for independence? Probability of A given B should be equal to the probability of what for independence? Anybody,
They
by
need,
the way.
they
Sorry?
need to they need to be the same. So
Who needs to be the same?
the PA and PB.
No. You're saying that PA equals PB means independent. No, that's not it. That means they're equally probable. Doesn't tell you anything about independence. To check for independence, there's one simple rule. It's always going to be the same. The probability of the event, the first event, given that the second event had happened, must be the same as the event probability of the first event happening anyway. This is a very logical statement, by the way. If I tell you that the probability of something happening, given that the other thing has happened, is the same as the probability of that something happening anyway, that means that me telling you that the other thing happened does not affect the probability of the first thing. Like, for example, if I tell you that the probability of getting a 6 on a die, given that I earlier got a heads on a coin, is the same as the probability of getting a 6 anyway. This means that getting a 6 does not correlate or like depend at all on getting a heads. Of course it doesn't, right? That's how you check independence. If this happens, if this is true, then getting a 6 and getting a heads are independent of each other. Do you understand that idea now? So this is the requirement for independence. Now, we already know the value of this. It's 5/8. What's the value of probability of A? Anybody? Probability of A. Jessica, Sophia? What's the probability of art?
7 plus 5.
That's 12. Probability shouldn't be more than 1, should it? 7 plus 5 is the number of people taking art out of 16 people. So what's the probability of picking someone who's taking art? There's 12 people taking art out of 16 people. So 12/16, right? Sometimes they give you probabilities in the Venn diagram. Sometimes they give you number of people. Okay, so remember, to find the probability of art, you don't have to simply add these up. That's not going to be the answer because these are not probabilities. These are number of people. So we do 7 plus 5. That's the total number of people taking art, 12. And then we divide it by total number of people in general, 16. So that means the probability of taking art is 12/16. If I simplify this, it's going to give me 6/8, which is 3/4. Clearly, the probability of A given music is not the same as the probability of A anyway, which means that, so they're not equal basically, right? Which means that A and M are not independent. So, whenever someone asks you, this is the third time I'm saying this, whenever someone asks you to check if two events are independent, check the probability of A given B, and then check the probability of A, see if they're equal. If they're not equal, they are not independent. If they are equal, they are independent, and that is it. Okay?
Yeah.
Perfect. And the final question is, two students are now selected at random, one after the other. Find the probability that the first student takes only music, second student takes only art. So, probability of the first student taking only art, or what? First student taking only music, and then only art. Okay? How do we do this? What's the probability of, out of these 16 people, I pick someone who only takes music. What's the probability of that happening? Out of these 16 people, the person I pick only takes music. What's that?
Would it be 3/16?
Yep. The probability of someone taking only music would be 3/16. But now here's where it gets fun. Of course, I want the next person, like I want an AND situation, right? AND means to multiply the probabilities. Now, remember that I've already removed a student from the list now. Person that takes only music. So, what's the probability that the next person I will pick out of the remaining kids only takes art?
7/16.
7 over 15. Because there's one less person in the list. Exactly. So it's going to be 7 over 15. That's the answer. Is this clear?
Mm-hmm.
Perfect. So I hope that you guys have understood the idea of independence, because there's really no more examples that we can do that, make it more simpler. I'm gonna give you guys another question. Did I give you question 40 as a homework question?
I don't think so.
Okay, so take 40 as another one, because the last part of 40 requires mutual exclusivity and independence. So make sure you guys try that out too. And in the next class, we're gonna start talking about tree diagrams. Okay. And after that, we're gonna move on to calculus. Sound good?
Yeah.
All right, perfect. All right then. I'll see you guys next time.
Okay.